Hey there, Round Rock ISD kindergarten teachers. Welcome to this explainer. You can totally think of me as your personal instructional coach today, here to give you a quick, super enthusiastic, peer-to-peer walkthrough of your 10-session Setting Up for Science unit. We know that whether you're a brand new teacher or a seasoned pro, prepping for a new unit just takes a ton of time, right? So my goal is to streamline that whole process for you. We're going to dive exclusively into your unit materials to get you completely ready to confidently teach this foundational science unit. Let's get into it.
We have 5 quick stops on our roadmap today. We're covering the destination, the foundation, the roadblocks, the journey, and finally, the language. Oh, and just a really quick housekeeping note before we jump in, whenever we talk about our state standards today, we're going to pronounce the acronym as TEACS, rhyming with leaks.
All right, stop number 1 on the roadmap, the destination. We're taking a look at your unit TEACS and what student mastery actually looks like.
So we've got 4 priority TEACS for Unit 1, and these standards are absolutely crucial because they build the foundation for how we actually do science in your classroom. K1B is all about getting students to plan and conduct simple descriptive investigations, and to start using engineering practices to design solutions. Then we have K1G and K2A, which are all about models, developing them, using them, and figuring out their basic advantages and limitations. And finally, K4A asks students to explain how science, or an innovation, can genuinely help people.
Now, translating those formal TEACS into everyday teacher speak, what does mastery actually look like for a 5 or 6-year-old? It's pretty straightforward. It just means your kindergartners are safely asking why and how. They're testing out their ideas using simple tools, and they're building models to show what they've learned. By the end of this unit, they should walk away understanding that scientists and engineers are just people who look at the world and solve real problems.
Moving right along to stop number 2, the foundation, or the core science itself.
The real game changer for this unit is understanding the difference between scientific practices and engineering practices. And for your kindergartners, you can explain it super simply. Scientific practices, that's what we do when we ask questions and conduct investigations to understand the natural world. It's all about discovery and asking why. Engineering practices, on the flip side, happen when we spot a problem and actually design a physical solution or a prototype to fix it. Basically, scientists ask the questions, and engineers build the solutions based on those answers.
A brilliant example of bringing the STEM connection to life for your kids happens right on day 1 with George Washington Carver. He was an agricultural scientist and an inventor. So he loved plants, studied them intensely as a scientist, and then used that scientific knowledge to engineer and invent things like soap, paper, and glue from peanuts and sweet potatoes. This hits TEACS K.4a perfectly. It gives students this fascinating real-world example of how someone uses science to create innovations that help a lot of people.
Let's transition to stop number 3, the roadblocks. We need to talk about common misconceptions.
It's really interesting how everyday words can completely throw our young learners for a loop. For instance, when you say the word design, a kindergartner naturally thinks of coloring or decorating, right? You'll need to explicitly teach them that to an engineer, design means to make a plan. Or when you say model, a 5-year-old might picture someone modeling a sparkly dress on a runway, rather than a physical copy of a real object. They also tend to think that models worked perfectly on the very first try. So you'll have to reinforce that models actually have limitations and usually need to be revised. And finally, just remind them that inventors absolutely rely on science to create their brand new tools or medicines.
All right, step 4, the journey. This is the sweet spot, your investigations and modifications. During your hands-on sessions, you're going to guide your students through the 6 steps of the engineering design process. They're going to identify a problem, brainstorm ideas, make a plan, test their design, improve it, and then communicate what they found out. Providing this specific structure gives your 5-year-olds a really safe, deeply predictable routine to successfully tackle what are actually pretty complex tasks.
For example, fast forward to day 4. You'll be running a descriptive investigation comparing sweet potatoes, which is an awesome callback to George Washington Carver, by the way. Students will find the longer sweet potato, measure it, and compare. Now, the source materials specifically note that to center equity and access here, you should use familiar objects and accommodate different motor skills. So actually scratch the traditional rulers, have them use paper clips, connecting cubes, or other familiar manipulatives to measure the length. It's a ridiculously simple modification, but it makes data collection completely accessible for every single student.
Then on day 5, brace yourselves because things are going to get a little louder.
Students will follow the engineering design process to build a noisemaker. You'll set up materials like paper cups, string, large beads, craft sticks, and tuning forks. Your biggest job here is safety and facilitation. Because TEKS K1C requires identifying and demonstrating safe practices, you need to make absolutely sure you clearly model how to safely test these designs in your classroom before you hand out a single bead or stick.
While you're managing all these investigations, keep these vital equity and access modifications in your back pocket. For your emergent bilinguals, or any students needing a little extra support, the curriculum highly recommends integrating storytelling, role-playing, and actually allowing students to physically act out the steps of the scientific process. Facilitating flexible grouping, where students work with peers of different abilities, is also just a fantastic way to ensure everyone is safely and actively participating.
And finally, step 5, the language. Let's talk about vocabulary and your interactive word wall.
Here is the exact vocabulary breakdown for this unit. Notice the critical distinction here. Your content vocabulary features those action-oriented science terms like engineer, investigate, problem, and prototype. Meanwhile, the supporting vocabulary contains the vital building blocks of scientific explanation, words like claim, evidence, data, and reasoning.
So, the million-dollar question is, how do we effectively teach this? Well, according to your English language proficiency standards, which are integrated right into this unit, we are absolutely not just stapling these words to a bulletin board before the kids show up. You need to provide visual and contextual support. To introduce these terms authentically, you're going to build the interactive word wall with the students by pairing the words with familiar objects, student-drawn art, and physical gestures. For example, when a student builds their noisemaker, that's when you add the word prototype to the wall, right alongside a drawing of their actual cup and string creation. You're connecting that abstract English vocabulary directly to their concrete classroom experiences.
By explicitly teaching those priority TEKS, guiding students safely through the engineering design process, correcting those sneaky early misconceptions, and anchoring the whole thing with a visually rich interactive word wall, you are setting the absolute perfect foundation. You're completely ready to teach this unit. So I'll leave you with this thought. When you hand a kindergartner a pile of paper cups and some string, they usually just see a toy. After this unit, what real-world problem are they going to see? And what incredible solution will they engineer next? Have a wonderful time exploring science with your kids, and we'll see you for the next explainer.